My task today is to update you on some of the conversations and activities that have been going on related to the experimental community. Okay, I know how this works now. Related to the experimental community, and in particular, when I say experimental, I really mean any laboratory-based science that's related to SZ4D. Laboratory science is a part of all three working group plans. This is just some of the most common fields of laboratory science, but many of these are actually in all three of the working group plans, and they're all also part of these cross-cutting themes that Joan talked about earlier. And so important is that not only are the processes that we come to understand and the properties overlapping and cross-cutting themes, but a lot of the infrastructure needs are also cross-cutting across the different working groups. And some of that infrastructure we already have, but maybe we want more access to, or we want to involve in collaborative science, and some of that infrastructure we don't yet have. And so the experimental work or the laboratory work actually has quite a bit of synergy and really needs to be integrated in a collaborative way, or at least that's come out of our conversations with the other activities that you're going to hear about. So the modeling and the field geology. So modeling can inform the experiments that we need, and the experiments can inform models as to the processes that we need to understand. And field geology likewise can inform the processes that are happening in the earth, but a lot of times to quantify those processes, we really need laboratory data. And so there's a lot of overlap here between the conversations that should be happening between these groups, but then also all three of these together are really needed to interpret and guide a lot of the array observations. So there have been a lot of conversations that have happened over the past few years related to the experimental and laboratory communities. So actually before the RCN was even funded, there was an NSF funded workshop in 2018 at Washington University in St. Louis on experimental studies of subduction zone processes that was largely focused on experimental petrology and rock deformation. And then in April 2021, like Kristen just mentioned, we had this virtual town hall that was combined for field geology and experimental plans. From that, there was actually a subcommittee of experimentalists or laboratory scientists from across that list I showed you earlier that met to discuss kind of coordination of laboratory and experimental activities. And out of that came this idea of having a laboratory and sample consortium as a facility as part of SZ4D. And there have also been some very specifically experimental rock deformation activities, which I'll also talk about. So that community has self-organized. There was an online workshop in June to talk about experimental rock deformation data needs, which followed up with another ad hoc committee I'll discuss in more detail later in an in-person workshop. So first I'm going to talk about this laboratory and sample consortium. Again, this is meant to be inclusive across all laboratory science and SZ4D. So what we really want is input from different laboratory communities about how this concept could best fit their needs. But the goals were really based on community input, was to leverage a community structure to collect the important data that SZ4D needs to answer those big science questions. And so the goals of having some sort of consortium would be to coordinate the collection of the data that is critical to answering these questions, while still valuing sort of the creativity and flexibility that scientists thrive with, to promote collaborative experimental research, so across subdisciplines in this cross-cutting theme kind of way, and then to also increase the accessibility of laboratory science and training opportunities to early career scientists. So we came up with a sort of a overarching structure for this, but again, would really like feedback from individual fields about subfields about how this could best meet their needs. But the idea would be to have support within SZ4D to coordinate laboratory and visits and exchanges. So by support, just logistical support to help make that happen is actually incredibly valuable, but then also virtual infrastructure that allows people to learn and understand about each other's facilities and equipment and opportunities to put people in touch with one another. This would also mean access to SZ4D samples and resources, and then potentially funding for student and postdoc-led projects. And of course, there are already some existing consortia outside of SZ4D that do some elements of this, and we don't want to reinvent that. So finding ways to interface with those while also directly answering SZ4D questions. So this is kind of the goals and basic framework. Feel free to provide, we'd love feedback in the breakouts about how this could best meet laboratory science needs. The experimental rock deformation community specifically has self-organized quite a bit and has already gotten going on some of this. So I wanted to actually talk about where they've gone. So as experimental rock deformation is called out in the implementation plan, both in terms of activities and data needs. But in particular, there are a lot of important and interesting questions that require experimental rock deformation data that we don't actually have the technical capability to collect or to collect easily. And so in the Catalyst proposal, then there was some funding for workshops for community input, and like Emily said earlier, a modest amount for technical design. And so I'm just going to talk about some of those activities. So there was a workshop at the beginning of the summer where we got feedback from the community on some of our technical needs to answer these questions. And so following that online meeting or workshop, then a subgroup of experimental rock deformation folks met weekly over the course of the summer to, as you might imagine, or maybe not, develop traceability matrices. Yeah, we made 9 of them. We made 9 traceability matrices. 4 for FEC, 3 for MDE, and 2 for LNS. So these are experimentalists from across all 3 working groups. And so what we did was we went through the driving science questions without prejudice and just asked, well, what information do we need from the experimental rock deformation community to answer it? What conditions do we need to collect that data? And then these are all color-coded by what we can do easily, what we can do, but it's not very easy or standard, and then what we can absolutely not do. And so all we did was compile this information so that we could take this to the rest of the experimental rock deformation community and start to prioritize it. And so our prioritization happened at an in-person meeting in Maine following a Gordon conference. So there were 40 participants at that meeting. And so we went through the stages of going through the traceability matrices and identifying the highest priority information that is needed to answer those questions. Then we asked the question of, well, what can we already do? And what do we need technical advancements to do? And then once we figured out what we actually needed to develop technology to do, we asked the question, well, what is best achieved through a community effort? And what can an individual PI do in their own lab? And so we came up with sort of 4 recommendations or needs to really advance different aspects of SZ4D science. And the first one actually relates back to this concept of a laboratory and sample consortium. So I'm going to start there because this is really the deformation community outlining the needs that it has from a sample repository. And we would like, again, more feedback from the rest of the community on what other laboratory communities and what they also need from a sample consortium. But the rock deformation community identified the need for a repository where we can store and distribute samples. Often we need large samples or difficult to acquire rocks and minerals. We desired standard characterization, so we all weren't characterizing our rocks in different ways in our own home laboratories. Potentially materials for voluntary comparisons so we can compare across laboratories. And we talked about the fact that we should probably try to exploit existing repositories, not to try to build one from scratch. And so the other piece was, and Kristen talked about this related to the field geology, is the need for some means of distributing both data. We want to store and distribute our data, so virtual infrastructure, but also technical information. So it's often very hard in the experimental community to get information about how the other labs do what they do, their jacketing materials, for instance. And so some way to communicate that so that we can standardize some of these experiments a bit more. And the rest of the recommendations were all based on answering the technical aspects of the science question. So we realized that there were a handful of technical limitations that we have that could be overcome potentially if we just had access to a bit more engineering support. That it might be prohibitive for one lab to find and invest in a person, but that together we might be able to actually have centralized okay, so we wanted centralized technical development. move on. The second part of that was, so the SZ4D part, the time component, was support for beamline support for in situ experimentation. This is cutting edge science that really allows us to get at what's happening in time during subduction zone processes. And then the third part was this data that's incredibly hard for us to collect, but actually directly controls stress state, the extent of the seismogenic zone, mode of slip and healing, all parts of the subduction zone, the driving science questions. And so this is a distributed model of experiments that would allow us to collect deformation data across laboratories to bring back and compare. So happy to take any questions, and also would love input in the discussion.